All right, let's dive into some chemistry that's hiding all around us, in plain sight. We're going to find out what makes lemons so sour, how soap actually works, and even how a little bit of science can look an awful lot like magic.
Okay, let's kick things off with something I'm guessing many of us have experienced. You know that sharp, stinging feeling you get from an ant bite? What's really going on there?
Well, the answer is actually really simple. When that ant bites, it injects a tiny amount of a chemical called formic acid. And that little drop of acid, that's our first big clue in this whole chemical mystery.
And this leads us straight to our first suspect, acids. They're the reason for that ant bite sting. And as we're about to see, a whole lot more.
So what exactly is an acid? Put simply, it's a type of chemical compound that has certain properties, like a sour taste. And they are literally everywhere. I mean, you've probably already eaten, touched, or used a few different acids today and didn't even know it.
Think about it. That sour kick you get from a lemon, that's citric acid. The sharp taste in vinegar comes from something called acetic acid. Even the tangy flavor in yogurt and buttermilk is thanks to lactic acid. And because all of these come from nature, from plants and animals, we call them natural acids.
But that's just one side of the story. There's another whole category called mineral acids. These are cooked up in labs from minerals, and they are often way stronger. Imagine the difference between the citric acid in your lemonade and the powerful hydrochloric acid they use in factories. It's a huge gap in strength.
Okay, now it's time to meet the chemical opposite of an acid. If acids are all about being sour and sharp, their counterparts are, well, they're slippery. Let's talk about bases. The number one way to identify a base isn't by its taste, and you should definitely not go around tasting these things. It's all about the feel. A base feels kind of soapy or slippery when you rub it between your fingers.
And just like acids, bases are all over your house. The most obvious one is soap, of course, but they're also in things like lime water and a lot of glass cleaners. Their slippery nature is actually what helps them dissolve all that dirt and grime.
So we know acids can taste sour and bases can feel slippery, but you can't just go around tasting and touching unknown chemicals, right? That's super unsafe. So how can we tell what something is? Well, sometimes we can actually make a base to see how it works. Check out this cool experiment. You take a magnesium ribbon and burn it. It creates this incredibly bright light, and what's left behind is a white ash. That ash is called magnesium oxide. But here's the cool part. When you dissolve that ash in water, a chemical reaction happens, and you've just made magnesium hydroxide, which is a classic base.
But for testing chemicals you already have, you need a much safer way. And that's where indicators come in. You can think of them as little chemical detectives. They change color to give you a clue, revealing the secret identity of whatever you're testing.
And these indicators give us really clear signals. Take something called phenolphthalein. In an acid, it's totally colorless. But put one drop in a base, and boom, it turns this awesome bright pink. Then you have methyl orange, which does the opposite. It turns red in an acid, but yellow in a base. It's like having two different tools for the same detective job.
Okay, let's put this new knowledge to the test. With what we know now about indicators, can we bust a classic magic trick? Can you actually make a lemon look like it's bleeding?
No way! What looks like magic is really just some clever chemistry. A magician might have a knife that they secretly dipped in methyl orange. So when they cut into the lemon, that methyl orange on the knife immediately reacts with the citric acid in the lemon juice. And what color does it turn in an acid? Red. Looks just like blood, but nope, it's just science.
So, we've seen how acids and bases work in our kitchens and in the lab, but these same ideas play out on a much bigger stage. I'm talking about our entire planet.
I'm sure you've heard of acid rain, but what is it really? Well, it happens when pollution from factories, gases like sulfur dioxide and nitrogen oxides, go up into the atmosphere and mix with the water in the clouds. That chemical reaction actually turns the rainwater into a weak acid.
And this is where you can really see the power of acids over a long time. Just like a drop of acid can fizz on a piece of marble in a lab, acid rain slowly, year after year, eats away at stone buildings and famous monuments. It's also really damaging to forests and lakes.
We've seen what acids and bases can do all on their own. But what do you think happens when these two chemical opposites finally get together?
This is where it gets really cool. When you mix an acid and a base together in just the right amounts, they cancel each other out. It's amazing.
This reaction is called neutralization, and what you end up with are two totally new things, a salt and just plain old water. Here's a perfect example. If you take a really strong acid, like hydrochloric acid, and mix it with a strong base called sodium hydroxide, they completely neutralize each other. And the salt they create? It's sodium chloride, which you probably know better as table salt.
And that reaction leads us right to our final topic for today, the surprisingly big and important world of salts.
See, when a chemist says the word salt, they're not just talking about the stuff you put on your food. That's just one type. In chemistry, a salt is any compound that's made during one of these neutralization reactions. And here's the most important thing to remember. Salts themselves are not always neutral. Depending on how strong the acid and base were that made them, a salt can end up being acidic, basic, or neutral.
So there you have it. From the sting of an ant bite, to the shine on your windows, and even why old monuments slowly wear away, the chemistry of acids and bases is happening all around us, all the time. You kind of have the key now to understanding this hidden chemical world. So think about it. What other everyday mysteries, what other bits of magic do you think you could explain now with science?